didn't like almonds, I could just pick them out of this trail mix, right? Easy. But what if I wanted to separate the sugar from this fruit punch? Yeah, not happening, right? So why is one of these snacks so easy to separate while the other requires way more effort? We get into all about the delicious science of mixtures and solutions right now. Now, these two things might seem very different, but scientifically, they're practically cousins. Let's first start off by talking about mixtures. A mixture is two or more materials put together or combined. Now, mixtures are all around us, from soups to sands to salads. Oh, this video is already making me hungry. Don't judge me. Now, it doesn't matter what state of matter the materials in the mixture are. They could be a solid, liquid, gas, or all three. What does matter is that when you combine or add those materials together, they keep their same chemical composition. For example, when I put this almond in the trail mix, it's still an almond. It still has the same chemical identity as it did before I put it in. So any combination of solids, liquids, and gases is a mixture as long as it follows this rule. You can mix a bunch of solids together like with this trail mix. You can mix a liquid and a solid like with this delicious fruit punch. You can even mix a bunch of gases together. Air is actually a mixture of nitrogen, oxygen, and a bunch of other gases. Love you, air. Thanks for helping me breathe and stuff. You can even mix all three, and you probably do all the time. If you've ever put a carbonated beverage in a glass and added ice, you have solids, liquids, and gases. So those are mixtures, but I'm thirsty, so let's get back to my delicious fruit punch. This fruit punch is a special kind of mixture known as a solution. A solution is when a solid material dissolves into a liquid. Now, the solid material, when it dissolves, becomes so small that you can no longer see it with your eyes. Solutions have two parts: the solute, which is the material that dissolves into the liquid, and the solvent, which is the liquid that the material dissolves into. If you've ever made lemonade, chocolate milk, Kool-Aid, or any other drink from a powder, you've created a solution. Let's make a fresh batch of fruit punch. In this case, the solute is the fruit punch powder, and the solvent is the water. The powder, or solute, dissolves into the water, or solvent, creating the solution. Make sure you stir it well. Stir that thing up. To try and help my students remember this, I used to tell them that the ute goes into the vent. The solute dissolves into the solvent. Now, what is a ute, you might ask? I have no idea. I would assume it's some kind of like Yeti-ish creature. I just thought it was catchy, okay? Sorry. The ute goes into the vent. It's honestly a little bit too bad that it's called solute and not sol-yeet. I honestly think you students would never forget it if it was sol-yeet. Missed opportunity, guy who names sciencey things. So a solution is a mixture, but a mixture is not always a solution because material doesn't always dissolve when you combine it together. There's also a big difference in how you can separate these two things. You can separate a mixture using physical properties. For example, I could use my eyes and pick out all those pesky almonds in this trail mix based on size, color, and texture. But it's not always that easy. If a mixture is a little bit more complicated, I could try separating it using a filter. Let's say I added water to the trail mix. I know, it's kind of gross, but it's for science, people. I could separate this new mixture by pouring it through a filter. The particle size of the trail mix is too big to pass through the small holes of the screen filter. It will separate the solids from the liquids in the mixture. You can also use the properties of density or magnetism to separate a mixture. You may have noticed that when I added water to the trail mix, some of the materials floated to the top while others sank to the bottom. That's because these materials have a different density. So that's how you can separate a mixture based on density. If something in a mixture is made of metal and magnetic, you can also separate it using a magnet. Take a look at this mixture of rubber bands and paper clips. When I hover a magnet over the top, it separates the magnetic paper clips from the non-magnetic rubber bands. I got them all. Booyah! Separating a solution is a little bit more of a pain in the batuski. Alright, the solute, or particles that have dissolved, have become so small that they can pass through even the smallest of filters. So you really can't separate a solution with a filter. Even if I use this coffee filter, which has teeny tiny holes, the full solution still passes right through it. I don't separate anything. And I know that because the water is still red, or the solution is still red. If I was able to separate the mixture, the water would no longer be red, and the fruit punch would no longer be delicious. To separate a solution, you actually have to use evaporation. I left this mixture of salt and water out overnight. Now the water evaporated, but the salt didn't. reappearing as crystals in this little dish. I have successfully separated this solution. Alright everybody, that's all the time we have for today. Remember, a mixture is two or more things put together or combined. A solution is a special kind of mixture in which a solute dissolves into a solvent. Now you can separate both of these things. A mixture is a lot easier to separate than a solution, which requires evaporation. See you next time.